Welcome back. In this lab video today, we're going to cover the Security Plus lab series, Securing Data with Encryption Software. So we're going to cover the Veracrypt encryption tool using a Linux, Kali Linux distribution. And this kind of ties in with this week's lecture on data protection and endpoint security protection, right? So we're going to encrypt some data, encrypt a particular file, and create a container for that. And we'll see how we can also add other files into that as well. And we'll kind of talk about the difference between, encryption and hashing as well. So let's go ahead and get started. I'm going to go down to the start of the lab. In this lab, we're only going to be using the Kali machine. So I'm already logged into lab 16. Securing data with encryption software. So we'll go ahead and load up the Kali machine. And the default password here is just Kali. And the first thing we want to do is open up the terminal. So we could either launch it from the top taskbar here. In the lab, it's saying we could also right click and choose open terminal here. So I'll go ahead and do that. And let me go ahead and I'm just going to make the text a little bit larger. Oh, it looks like I already did. All right, cool. Yeah, I changed it to 13 so we can see it a little bit better. So the first thing the lab has us do is type out this command touch billing.txt. And essentially what this is doing, the touch command in Linux is a way to create a file. So we basically just created an empty file called billing.txt. And also in Linux, we could list out the contents of the current directory by using the ls command. So you could see the billing.txt here. We also see a couple directories, one being captures and the other is steg. Another nice tip for listing out files in Linux, if we do ls-l for a long listing, you can see it gives us a slightly different output, and it still displays the same files, but it shows us, date created, when it was last edited, and also permissions as well. Not something you need to know for this lab, but just something that I wanted to point out to hopefully get you comfortable with some of these very common Linux commands. So now that we've created that file, next part of the lab, we're just going to launch Veracrypt by typing that out in the command line, and you see that it actually launches a graphical user interface of the Veracrypt tool. So the first thing we'll do is we'll create a volume. So we're going to create an encrypted file container, and we'll just keep it standard. And from volume location, we're going to pick a specific file, and we're going to choose that new billing.txt. So that resides on our desktop. So I'm going to go ahead and double click that. Already exists, you want to replace it? Yes. So we're essentially going to be replacing this with the new encrypted version of it. So we'll go ahead and replace, choose next. And here you can see we can select different encryption options. So it is by default set to what the lab is telling us to select. But as you can see, there's all these different encryption algorithms. Each one is going to have different levels of encryption, but I will say AES Advanced Encryption Standard. This is the industry standard at the moment. It's definitely one of the top encryption standards. And down here, we could also change our hash algorithm if we'd like, but we do want to leave it on SHA-512. You can see that there's a SHA-256. And really what this means is the SHA-512 is going to be much stronger, use a much stronger algorithm than 256, for example. So SHA-512 is definitely the best. And, real quick, actually, just to help you understand the difference between encryption and hashing. So remember, we use hashing kind of as a fingerprint. It's a way to validate the integrity of a file to make sure that it hasn't been altered and changed in any way. So if I come to, let me create a new tab, and this isn't necessarily part of the lab, but just something I want to demonstrate to you. So remember, we have that billing.txt file. So what I could do, I can get a SHA-256 checksum of that file by running the command SHA-256sum and then the billing.txt. And what we see here is a hash of that file. And if I run it again, another Linux handy tip, if you just press the up arrow on your keyboard, it will bring up previous commands that you ran. That's why I was able to just bring up that SHA command once again. But if I run it again, you notice that it is exactly the same. That is because it is once again, a fingerprint of the file state at that time. And of course, it is just an empty file, but it's a file nonetheless. Now, notice that if I run SHA-512sum on billing.txt, we have a much longer hash. And this is because the algorithm is much stronger. So it's adding more confusion to the hash, and it's making it longer. Now, to kind of demonstrate how this is used to verify the integrity of a file. So imagine if I was sending you billing.txt and I say, here's the SHA-256 hash of this, and I send you this string. But what I'm going to do real quick is, and in fact, you know what, let me clear this screen and make it much simpler. Okay, so we have the SHA-256 hash. Now, if I just echo, I'm going to echo the word hello into billing.txt. It's more just kind of general, very basic Linux scripting here. And if I view the contents of billing.txt, you see it now is no longer a blank file, but it has the word hello in it. Well, what happens if we run the SHA-256 checksum on it again? We see that the hash is completely different. So if I sent you this hash, emailed you the file, and then you downloaded the file and ran your own checksum on it, and notice that it's completely different, you'd be able to determine that, hey, this file has changed somewhere in the process. Maybe it was, grabbed by a threat actor in the middle of the transfer, and they added something malicious to it, right? So that is largely a big component of what hashing is used for. So I just kind of wanted to give that demonstration so you can understand the difference. Oh, whoops! I just close out everything? Give me a second. Let me launch Veracrypt again. There we go. So let me run through this again real quick. I need to create my volume. And again, all that stuff that I just did, you don't have to do it. I just wanted to do it for demonstration purposes. Okay, so we're back to where we were. So we're keeping AES and SHA-512 for the hash. Volume size, we're just going to drop in 50 here, 50 megabytes. And we'll set a very simple password of just password. And in fact, I'm pretty sure it's going to yell at us and say, hey, that's very simple. Yeah. So short passwords are easy to crack using brute force techniques, which is very, very true. But again, just a test lab here. So, and it's all locked down in sandbox. So, okay, we're going to keep it at FAT file system type. I want to say that stands for file allocation tables, I think. Yep. So we'll keep that. So this is interesting. So encryption is all about adding as much confusion to the algorithm and to the whole process as possible. So as you can see, this bar here is moving, and it's because I'm moving my mouse at very random movements. So the more you move your mouse around, it has to be within this window here. You can see if I move it outside of it, it's not changing. But within it, the more I move my mouse randomly, it is adding more confusion and making the overall algorithm stronger. So feel free to play around with that as long as you like. You could try and fill up the bar, or you can move forward. I'm just going to go ahead and move forward. We're about halfway there. Click Format. So Veracrypt will not encrypt a file, but it will delete it. So it's deleting the original file and replacing it with the new Veracrypt container. All right, very good. So yeah, you see here in the lab notes, the higher the randomness, the secure the encryption. So it's all about randomness. Okay, so we can exit out of there. Next, we are going to select that billing.txt. So we'll go to desktop, billing, and we want to mount it. So we're going to mount that into slot 1. And so it's going to ask us, okay, we want to mount this, so we need to know the password, which is just password. And if you think you might have mistyped it, you could display the password there. And then next, when it's asking us for the administrator password. So remember, this is the password that we use to log into Kali Linux, which is just Kali. Very good. And we see that it's mounted in the media directory and created Veracrypt 1 mount point there. And we could also see it on the desktop listed under this 52 megabyte volume. So we can go ahead and copy something into that. So there's the steg folder here. We could double click on that. We have these 2 files. Now we could click and highlight those and drag them in. That would be one method. Lab is also telling us we could press Control A, select all, right? And then Control C as another shortcut for copy. And then we can come down to enter into the container and press Control V. So we have now pasted the Cyber Monday and the top secret files into the encrypted container. And I believe the last thing we're going to do, so now we're just going to go ahead and dismount that. So now at that point, we could, potentially delete those files from the steg folder so that we know that they reside strictly within that encrypted container, which of course, as you saw, you need the password to be able to mount that and to be able to actually access those files. And that concludes the lab. So hopefully you learned a little bit about, the difference between encryption and hashing. Also just in general, thinking about how you can use these encrypted containers to store highly sensitive documents. You don't technically always need to encrypt all of the things, but especially when, remember, we largely deal with encryption, especially when it comes to regulated data, personally identifiable information, credit card numbers, personal health information, things like that, intellectual property, and all of that. So very good. Thanks for watching, and I'll catch you in the next lab.